On today's agenda, we are studying function notation. The purpose of this is so that we can discuss and interpret the parameters of a function and actually use function notation while discussing it. Okay, so you're doing 1 through 35, obviously odd, not 36. Reason why it said 36 is last year I had them do all. All right, so let's just start with, you don't need to take these notes of this page, but let's talk about a function. A function is like a machine. It has an input and an output, okay? An input and an output. And they are here. We are putting the recording on hold. Come on in. Okay, so I'm abbreviating because we just finished the tour. Okay, so I have a number machine. I put a 2 in, and I get an output of a 10, okay? The input, what I put in is what we call our input. That would be the X. Our X is always the input. What I input, I put something into the machine, and the output is my Y, or the number that comes out. So if I put a 3 in, what would come out?
15.
A 15. If I put a 4 in, what would come out? 20. Okay, if I put a 5 in, right, and so on. We can predict it. What rule is happening inside this little number machine, this function machine? Noah? Times 5. We're being multiplied, whatever the number, the input, the X times 5. So it'd be 5X, right? That's what's happening. We can predict any. I can say, I don't have to go in order. I could jump down to 100. If I input 100, what comes out? 500. 500, right. Now, what we have here are ordered pairs. We can say this is like an equation. Our rule is like an equation where X is my input. I put 2 in. I get a 10 out of the Y. Does that make sense? Yeah. You don't really need to write these notes. I just want to talk about what our functions are. Now, many functions have a pattern, but not all, okay? I just want you. So here's basically, in this chapter, you're going to be given a word problem, something similar to this. Logan assembles outdoor barbecues for $8 each. Write a rule that represents his pay Y in terms of the number of barbecues he assembles. So it's telling us that barbecues he assembles is X. But I want you to ask yourselves, what depends on the other? Does his barbecues depend on the pay, or does his payment depend on the barbecues he assembles? Payment. So if payment is what is the depender, that becomes our Y, or our range, okay? And our domain would be his X or his barbecues he assembles. Does that make sense? Yep. So our range is our Y, it's our depender, it's our output. That makes the domain and the independent the number of barbecues. So they want us to build an equation. What would this equation look like, Gracie?
Y equals 8X.
Good. Now, the first part of what you're going to be asked to do is to write the equation. Part A, they'll give you a situation. Part A, write the equation. Part B, they're going to give you more information to use in the equation. Our Y is our output, our X is our input. So when they give us information to use, if Logan assembles 20 barbecues last week, what would he get paid? Are they giving me the input or the output?
Input.
The input, so I substituted in for X, and then we end up with Y is equal to 160. It is not beyond them to give you an output. If they give you the pay, we're substituting it in here for the Y, and then we're solving for the X. Does that make sense?
Yep.
So part A is write the rule. Part B is use the information in the rule. Does that make sense? Mm-hmm. All right. I'm going to kind of skip some of these because I want to jump to what we're doing, and we're kind of behind right now. So I'm going to jump to, okay, let's take this word problem. I like this one a lot. How much would a 6-pound platter cost? What do you think? Can anybody figure that out? Okay, Elise, what do you think?
$9.60.
$9.60. How do you know that?
Because if you check the pattern, 210. If you subtract 360 minus 210, it's $1.50. And if you subtract $5.10 minus $3.60 is $1.50, and the pattern goes on and on.
Or if I add 150 to 210, if I add 150, so how are you getting the sixth pound?
You add 150 to 5 pounds.
And then we get 960. Perfect. Okay, so now we have to write an equation, okay? Remember a while ago we talked about our slope formula. M equals y2 minus y1 over x2 minus x1. You with me? Mm-hmm. Well, really what that's saying, I mean, we're basically just taking two points. I can find it that way. But another way to look at it is I can find the change in the y's and divide it by the change in the x's, right? The change, notice y is in the numerator, so y is always in the numerator, over the change in the x's. So what is my change in my y's?
150.
150, right? And what is my change in my x's? 1. Okay, it's a constant rate of change, and that's what we call our slope. Okay, so my m is 150. Can we figure out, that's without taking our 2 points. We can casually look at, the change. What else do we need to write an equation? What else do we need to write an equation? I have a slope, and I need one more thing.
Oh, a point.
A y-intercept. Can we figure out the y-intercept here? How? How would I figure it out? Noah?
You could look at 1 pound is $2.10, and so you would subtract 150 to get to 0 pounds.
To get to the 0, we always go to our 0 for the x. So I'm going to subtract 150, and what do you get?
60 cents.
0 and 60 cents, right? So I know my b equals 0 and 60 cents, right? So what would the equation look like? And let's use P for price and W for weight. So what is the depender? Is the weight depend on the price, or does the price depend on the weight?
On the way.
So what is my Y?
Y is the price.
P, right? So what would the equation look like? Okay, Gracie?
P equals 150x plus
150 what?
150x plus
Not X. We're not using X.
Oh, W.
W
150
plus
W
0 and 60. 0.6 or 0 and 60 cents. So 0 and 6 tenths. Okay. Now, I've got my equation. Does everybody remember how to do that? The change in the Y over the change in the X, and go to your 0. Now it says, how much would a 10-pound platter cost? Nicole, where would I put that 10 pounds?
For the W.
For the W. So I'm doing 150 times 10 plus 0 and 6 tenths. So I'm getting P is equal to 15 plus 0.6. And P is equal to $15.60. So for a 10-pound platter, it's $15.60. Is everybody understanding that? How to use the variables that actually come with the story? Okay, moving on. All right, so, yes.
I was double checking it, and for 5 pounds, it's $8.10, and $8.10 times 2 is $16.20.
Yeah, so the price, it doesn't automatically have to be double the price of the 5 pounds. Sometimes.
Yeah, it's not double
Okay.
because you forgot the initial 60 cents,
Oh, okay.
right? Okay, so, and by the way, that is our rule. I'm going to skip this question, these questions. Okay, we're going to jump to function notation, which is also in this chapter. So function notation is just a fancy way of writing. Fancy way we write the Y with our input. We discuss the input and the output all in the same statement. So before we were, if I know that if X is 1, what is my Y? 5, good. If X is 2, what is my Y? 7, right? If X is 3, 2 times 3 is 6, plus 3, Y is 9. If X is 4, Does everybody understand? If I write something like this, the f of 1, what they're saying is when the input, we would first say the f of 1. Everybody say the f of 1.
The f of 1.
The way I say this one is the f of x.
The f of that.
The function of x. So it's really talking about the function of 1 as an input.
Yeah.
Okay, so when 1 is the input, really what I'm saying is 2 times 1 equals 3. So the function of 1 as the input is what? Oh, sorry, that should be a plus 3. The function of 1 as the input is 5. Does that make sense? So what would the function of 2 be?
7.
Okay, and what is the function of 3?
9.
Good, and the function of 4? And what about the function of 10? Oh, you said 11, yeah. What about the function of 10?
23.
Does everybody understand? So it really is telling us what is the x, and this is the y. Okay? And this is just the fancy way to write the y. Does that make sense? Where we discuss the input with it. So this is what we call function notation. Here are two different functions, a g function and an h function. So if I'm talking about, if I want you to use the g function, I'm going to label it the g of 4. The 4 tells me what I input. So the g of 4, I would go to the g function, right? And I would say 2 times 4. The g of 4 equals what?
8.
8. This time, what function am I using? The h function, which is right up here. So I'm going to do the h of negative 2 equals 4 times negative 2 plus 1. So the h of negative 2 is negative 8 plus 1. So that makes negative 7. So the h of negative 2 equals negative 7. You guys with me? Okay, I'd like you to pause the recording and do the next 4 on your own. Go. Now check your work. Number 3 is negative 6. Negative 3 is negative 6. Shh. Number 5 is 25. Number 4 is negative 3. And number 6 is 18. Any questions? Please throw it outside. Don't throw it in here. Okay, so now it gets a little bit more complicated. We might have squares in our function. So you can see, like I might be doing, like number 3 is negative 3 squared. So the g of negative 3 is equal to 9. Does that make sense? Or you might have something like this, the h of 4. That means I'm going to do 3, I'm using the h function, times 4 minus 2 plus the g of 1 squared. Does everybody understand that? Okay? And now I have to simplify that. What does this simplify to?
Oh, that's 10.
That simplifies to 10 plus 1 is equal to what? 11. So the h of 4 plus the g of 1 equals 11. Does that make sense? Now let's look at number 7. Let's look at number 7. We work inside out. First we find the h of 3. So what is the h of 3? 3 times 3 minus 2, right? 3 times 3 minus 2. And put that all in its own braces. And then the outside, the g, I'm going to end up squaring that, right? So what does that equal to?
7.
So 9 minus,
7.
oh, that's supposed to be a 2. Yeah, it's 7. And then I'm doing the g of 7, which is 7 squared. So what does that equal to? 49. So do you understand how we work inside out? Okay, I want you to pause the recording and do number 6 and 8. Now let's check our work. Number 6, what's the h of negative 5? Who got what's the h of negative 5? Yes.
Negative 17.
Negative 17 times, what's the g of negative 2?
Negative 4. I mean, positive 4.
Positive 4. And so altogether it makes negative 68. Okay, who can tell me what the g of 2 is? Yes.
The G of 2 is 4.
4. And then the h of 4, who can tell me what that is? Go. Go.
Oh, the H of 4 is 10.
10. Does that make sense? Okay, so we have so much to do and I got to get through this. All right, so when we are doing evaluating functions, here's the thing. There's the way they give it to you. So what they want you to do to evaluate is find the value when x equals negative 1. So we basically have to do this. The f of negative 1 equals 4 times negative 1. And the f of negative 1 is negative 4. And then we've got the f of 0 equals 4 times 0, right? So the f of 0 equals 0. Okay? And then I have the f of 2 equals 4 times 2. So the f of 2, sorry, that's supposed to be a 2, equals 8. Okay, questions? Now, you can write your answers like this. My suggestion in your answer column is you do the f of negative 1 equals negative 4. The f of 0 equals 0. The f of 2 equals 8. The reason why is if there's another way to write this too. I could do negative 4, 0, and 8. Okay, I could do that. The problem is the order you put them in here is the order that they give them to you. So if they don't give them to you from least to greatest, you could potentially get them wrong because you put them in the wrong order. Does that make sense? If you the order doesn't matter if you tie it to the input, the answer. I don't care what order you put it in. But if you put this in the wrong order and you go from least to greatest and this was not given in least to greatest, you will get 3 points wrong. Do you understand? So it is best to always write your answer in function notation form, not this shortcut. Because it is assumed if I gave you, let's say I was given let's say it went like this. Let's say I gave you 2 and then 0 and then negative 1. And you gave me the answers like this, it would be marked wrong. Because the first one in the braces has to be the answer for the first question given. Does that make sense?
Yes.
So order matters. Okay, I'm going to move on from this. Is that okay? Mm-hmm. You guys feel okay about this? Okay, I'm going to skip some of these. All right, so here's an example from the book. The f of x equals negative 4x plus 7 when x equals 2. So we're doing that, right? I'm just substituting in the 2. The f of 2 equals negative 4 times 2 plus 7. Are you guys with me? Mm-hmm. And then I simplify it, and so I say the f of 2 equals negative 1. I would write it, don't write it like they did it in the bottom. I want you writing it like this, with the input. Okay? And then you got to try the same thing with negative 2. Does that make sense? Mm-hmm. Substituting in negative 2, and then giving me the f of negative 2 equals 15. Okay? That's part 1. Part 2 of the homework. This is from the book. The f of t, the whole thing, represents Fahrenheit, temperature. Okay? Where t represents hours. What's the input here? What's the input? Is it Fahrenheit or hours? Hours. How do we know that? How do I know that hours is the input?
Because the temperature is dependent on the input, or what hour it is.
Okay, and why else?
The T is in the parentheses.
Because the T is inside the parentheses, but both of those are accurate. You're right. Okay, so it says explain the meaning of each statement. So F of T be the outside temperature in Fahrenheit, where T hours after 6 a.m. So what does A really mean? What does A really mean? What is the F of 0? 0 hours after 6 a.m. Keep going. It is what?
58 degrees.
Okay. Another way to say this, what is 0 hours after 8 a.m.?
8 a.m.
I'm sorry, 0 hours after 6 a.m.
6 a.m.
So at 6 a.m., it's 58 degrees. Right? Okay, B. What does that mean?
At 12 a.m.
6 hours.
At,
At 12 a.m.
at what time?
12 a.m.
No.
p.m.
At 12 p.m., the temperature is what?
The temperature
N.
Is N degrees Fahrenheit. Right? Okay, now let's look at C. Explain the meaning of C. So, what time does this represent? The F of 3. Noah?
3 hours after 6 a.m.
Which is what time? This is 9 a.m. And what is the F of 9? 3 p.m. Now, what is this statement saying? Go.
It was colder at 9 a.m. than it is at
It's
3 p.m.
cooler at 9 a.m. than at 3 p.m. Doesn't that make sense? Yeah. So it's really making sense of this symbolism. Does that make sense? Mhm. All right. So this is one of the last things that you're going to do. The h of x. Notice what they're giving me. Are they giving me the input? Do they give me the x?
No.
They're giving me the output. That's what that means. If they do h of x without anything inside here, then they're really giving you the output. And that has to be substituted here. Not inside, but for the whole thing. -7 equals 2/3 x minus 5. And we have to solve for the input. Does that make sense? Just like our word problem. Write the equation, then use the information and substitute in. So here we go. -7 equals 2/3 x minus 5. Add 5. Add 5. And we have -2 equals 2/3 x. I'm going to multiply everything by 3 over 2. Here it's going to cancel. Right? This will cancel. I'm left with -1 times 3 is -3 equals x. So my input is -3 when my output is -7. Did that make sense? Do you understand? Hold on. Do you understand the difference? Yes? Okay, hold on. Let me just make sure there's nothing else. Graphing, hold on. Graphing the f of x. Same thing. It's like having y equals mx plus b. You can find a table, substitute some negatives, positives, right? Or, unless they ask you to make the input-output table, I might. But if the homework doesn't ask, you can use mx plus b. Okay? And then we find our m and our b and plot it. Same thing. And that is the video. Let me go back really quick. Hold on.
Except for Ashley now.
Shh, I'm taping. So, one more time. If the question asks you to do an input-output table, which I guess for this chapter they're going to, because this is all about inputs and outputs. I want you to notice, guys, notice the input-output table. Look at the input and look at how they write the output. That's what's different here. So on this one, they're probably going to ask you to make the table because it really is all about input and output. So you're going to make some test points, choose your X's, and then plot your points. So if I choose -2, I put -2 times -2 plus 5. It's -4 plus 5 is 1. And then I'm going to do 2 times -1 plus 5 is equal to -2 plus 5, so it makes 3. Okay, and then you plot the points. The y is my f of x, the x is my x. Okay, and that is function notation.